see, record.
Good evening, gentlemen.
Good evening.
Good evening.
And ladies.
Howdy.
Okay, all right. Let's see. All right, well, thanks everyone for joining. The main presentation tonight, Bob Mix, KF6ABC, is going to give us a presentation on the tiny tuna. Give us an update on the DIY build and what's going on there. But we'll get started with our normal club business. Jojo, do you want to give us a treasury and membership update?
Sure. Good evening, everyone. And I'd like to share my screen.
Okay. Let's see. Yep, there you go.
Okay, and what you are looking at is our report for the month of April, which reflects the information from the prior month. And there isn't really much activity. We welcome our new members all the time, every meeting. And I don't know if Matt is here. He is our newest member. Welcome, Matt, KN6OGF. We have 121 paid up members for this year. And overall, there's 213 members. And this is composed of the general members as well as the courtesy and life and complementary members. And we have 73% who are ARRL members. We had an increase from last month. So next question is about our monies, and this is how much we received from last month for membership. And we always have a repeater donation of less than $10 from one donor, and that's David. So thank you, David Nick. And we spent $684 to cover the liability insurance, which we pay every year, and we are able to reimburse the cost in payments and flowers sent for Paul Gross. So thank you. We still have this amount in the bank in order. Okay, well, I don't have any other numbers, information, except for this agenda items that, again, we are thankful for the gesture we had for Paul Gross family. I wasn't able to visit. I don't know who was able to do anything physically, but we will still attempt to do it. We were able to get the confirmation that Michael and Lynn of Sacramento Medical Reserve Corps will be our guest speakers for next month's meeting. They will give us introduction and offer for voluntary opportunity to our members in joining SMRC. I'm a member of SMRC and have volunteered a few times, so I recommend it. Not this Saturday, but the next Saturday, finally we will be able to work on our bank account, so I can receive the information with how much there really is in the bank. And then we talk about having an incentive to try to get people renew early, and hopefully this will add more fun to our club as well as my engagement, and that will be a work in progress. But we have started the conversation to work on that. And then there's an elephant sale that we also talk about. Okay, and maybe for the additional tasks at hand, we'll continue to do our planning for additional events. However way COVID restrictions are being in effect, we could be doing picnic events or parks on the air event. And that is it for membership and treasury. If you have any questions, feel free to let me know.
Okay,
Thank you.
thanks, Jojo. Carol, you able to give us a club website and social media update this month?
Yes, definitely. You hearing me okay?
Yeah, good.
Very good. Okay, let me go ahead and share my screen. Here we go. There, how's that? Seeing it all?
Yep, that's good.
Yes.
Okay, very good. Yeah, this is a report for the website. I'm Carol, Killer Papa 4 Mike Delta webmaster for River City ARCS, and just a report on our website and online resources for the month of March. Okay, and just a reminder that our website is www.n6na.org, and we keep most of our information for the membership and also for the amateur radio community here at large at that website. We also are open to anyone who would like to give any contributions to materials to be put up there. Please contact us. You can contact me through contact@n6na.org. And next, reminder of our nets. Tomorrow night will be our Wednesday night net. Of course, the daily health and welfare nets are still going strong, and it's at 7:30 p.m. On the 145.25 megahertz repeater. Wednesday, we have our 8 o'clock 2-meter net, which is also accessible via Echolink and All-Star now. So we are regularly having check-ins via the internet. 8:30 is our 10-meter net, 28.420 megahertz upper sideband. And then our slow scan television net is 9 p.m. and that's on the 441.30 megahertz repeater. And that is also streamed live on YouTube as well. Our swap page, remember, is on the website. It's n6na.org/swap. And this is a service for our club members. Anybody who would like to post anything for sale or anybody might be interested in any items. The club does not guarantee the condition of the items. We're just offering the ability to post. And these are some new postings that just recently went up there. A couple of nice receivers. As far as the website activity, we had a little drop in activity compared to February, but still we had 2,454 page views during the month of March, and the most views were 153 on March 3rd, which was the day after our online meeting. The most active web pages are quite interesting. This month, the 10-meter page went up. And it actually was the most popular page. This is not our 10-meter net page. This is just a page of general information to try and encourage people to get active on 10 meters, especially try to get our technicians to get into HF operation. And all I can say is I think there's more interest in the band now because people are aware that the sunspots cycle is on the upswing, and we're starting to get some interesting propagation and actually some DX come through on 10 meters. So people are looking to find a little bit more about how to get on the air and what to expect there. And this is a little snapshot of our 10-meter page. It just has some general information about the propagation characteristics of the band and the different segments where you can operate CW or digital modes like FT8 and single sideband. So it seems to be quite popular now. The sources of our traffic into our webpage, again, 55.8% were referred to us by Google. And we had direct hits, so 34.5% directly to our n6na.org URL. And again, most of the visits were from California here and in the United States. And all these other countries in the world that have a little bit of blue color have also been, we've had visitors look at our website. Social media, our YouTube channel last month had 1,572 views. And we now have 306 subscribers. The most active YouTube video actually was, for some reason, the rig expert. We had one meeting a number of years back where there was an introduction to the rig expert, and that seems to be still very, very high activity. But the second one after that was actually our March 2nd meeting, which was the Solder Smoke Podcasters. And we've had quite a few views on there, over about 300 views so far on that video. It was a really good hit. Facebook page has 498 followers, and we have 138 followers on Twitter. And we have our Discord server. We have a discussion group there with 19 members. So again, if you would like to give us any feedback about the website, send the email to contact@n6na.org. And those are the, just to remind you, we have the Facebook, Twitter, and YouTube sites. And I did want to put a reminder out there to keep in the back of your mind to save the last full weekend in June for Field Day. And that's our major operating event of the year. And this year, the ARRL has renewed the ability for clubs to pool their different member station scores together as a club score, since we're still unfortunately under the grips of the pandemic. So it looks like we're going to have a replay pretty much of what we did last year, which was a lot of fun. So keep your eyes peeled for more announcements as to how to prepare for Field Day coming up in June. So back to Kevin. Thank you very much.
Thanks, Carl. And yeah, just a general reminder, if anyone's trying to get in contact with the club or any of the board members, you can always send us an email at that contact email address, and Carol will forward that on to the respective party. So that's the easiest way to get in touch with anyone at the club, any of the board members, if you need to get in touch. If you've got any suggestions of things we should be doing or shouldn't be doing, or like suggestions for topics for upcoming meetings, so shoot us an email and we'll get something on the calendar and get it planned. All right. Any other topics or any other information anyone has to share this week before we move on? Okay. All right. Let me see. Okay, Bob, are you on? Can I hand over to you for our main topic?
I'm definitely on. I'm ready, I think. I'll find out when I start talking, I guess.
Okay, over to you.
Okay, share my screen. Yeah. Well, my agenda tonight is pretty simple. I'm going to talk about two things: the Tuna Tin S transmitter and the TinySA spectrum analyzer. I have a picture of a tuna up here so you know what they look like before they're put into a tuna tin can. But I'll show you a couple of tuna tin transmitters after this. Okay. Most of us old hams remember radios with vacuum tubes. I got started in radio in the 50s, and but I learned about transistors real soon, and I thought it was pretty amazing that you could replace a vacuum tube with a piece of sand, a little speck of sand. And so I pretty soon got away from the vacuum tube receivers and transmitters that I built as a kid and moved on to transistorized gear. The hollow state age came before solid state, and then the analog age came before the digital age. The Tuna Tin name comes from an article in 1976 in QST. Doug DeMaw who's a legend to us, some of us older guys. He wrote an article called Build a Tuna Tin 2. It was called the Tuna Tin 2 because it had 2 transistors, and hams at that point were still leery of transistors. He wanted to get hams to start building their own gear and build the gear with transistors. So he came up with this idea of this little transmitter. Here's a picture of it. It was built in a tuna tin can. I'm sure he washed it out before he drilled holes in it and put connectors on the side and so forth. And then he designed a circuit board.
We still just see the fish.
Oh, really?
Yes.
You'll have to reshare a different.
Thanks for telling me that.
Or share the whole desktop.
New share I have to go to each time I do this?
If you share your desktop, then we'll see whatever you've got on your screen.
Okay, well, how do I do that? Not on the screen.
Well, go ahead and unshare what you've got, and then you should have a full set of choices.
Okay. All right. I have to stop that share and go to a new share. Okay. Are you seeing the Tuna Tin now?
It's still coming up. Yeah, we got something now.
Okay. So you're seeing Build a Tuna Tin too?
Yes.
Yep, that's good.
Okay, good. Okay. So he wrote this article. He designed a little transmitter and a circuit board that would install on top of a tuna tin. The circuit was this one. It was a 2-transistor transmitter, and it had 3 inductors. Hams in those days and hams today are a little scared of inductors and winding their own coils and so forth. So what Doug did was he went to Radio Shack and he found 3 chokes that were on sale at Radio Shack, and he modified those 3 chokes to be the inductors for this transmitter. And he made it easy for hams to go out and buy the parts at Radio Shack and build the transmitter. So that's basically what the Tuna Tin was all about. Okay. Navigating all of this is a bit of work. So I guess I have to stop the share again and start it each time I want to do something, huh?
Only if they're different applications.
Okay. All right. That really isn't what I wanted to do. Hold on. Screen sharing has stopped at the, okay.
If you share your desktop, then we'll see whatever you've got on your screen, if that's easier, rather than going backwards and forwards.
Okay, well, I have to find where it says shared desktop, I guess. Do you see the Tuna Tin S?
Yes, yep, that's good.
Okay, all right. In December, the QST came out and I saw an article called the Tuna Tin S, a bare bones synthesized QRPP transmitter. And this was the first page of it. What we're looking at is a Collins 75S3 receiver on the bottom with all kinds of vacuum tubes in it. And for those that are interested, it was a permeability tuned receiver, just like the TinySA receiver that Phil and I built. And I handed out 3 circuit boards to other club members to build the TinySA receiver. Anyway, sitting on top of this big boat anchor which we didn't think of as a boat anchor in those days. I mean, that was what the well-heeled hams had. The rich hams had those guys, and that was the state of the art. That was the gold standard of receivers and transmitters in that age. This particular receiver came out in 1967. And sitting on top of it is a Russian cookie tin that has the Tuna Tin S transmitter inside of it. Bob Fontana wrote this article. He designed the transmitter, and I read that article, and I thought that it would be a good project for some members in our club. And one of the things I liked about it was that it combined the analog and the digital era into one transmitter, one circuit. And it would be an opportunity to get people who hadn't had any experience with digital gear and Arduinos and so forth to get their hand in. And so I thought that we could have a project to build this transmitter. I contacted Phil and I said, what do you think, Phil? And I think that, you know, if we got some people to build this, that we could probably coach them through Zoom sessions to actually get it built. And I wasn't real enthusiastic. He said, well, that sounds like an idea. And then I work 40 hours a week, so I just periodically, I asked Phil, you know, what do you think? Still think that might be a good idea? And he says, oh yeah. And he didn't tell me what he was doing. Well, this particular transmitter has a digital section and an analog section. The digital section is composed of these four modules. U1 on the left-hand side is an Arduino Nano. It's a computer that runs software. Attached to that, on the right side, U2 is this OLED module, which is a display. And then to the right of that is the SI5351 clock generator. And below that is an encoder. The encoder is like a pot potentiometer. You turn a knob and you can pick a frequency. And the Nano then displays that frequency on the display, and then it tells the clock generator to send a signal out, an RF signal out at that frequency to the right to a transmitter board. So that's the basic block diagram for the digital half of this transmitter. And then further down in this article, it shows you the analog half. The analog half of the transmitter is really quite simple. The signal, the RF signal coming from the clock generator comes in from the left side, it comes to Q1, a transistor, a MOSFET transistor, to which the source pin is connected to a key. When the key is pressed, that causes the transistor to conduct and send the signal on to a bandpass filter to the right, and then on out to the right through this P2 connector to an antenna. So that's a pretty simple circuit. I thought both of them were simple circuits. Combined together, we could build a CW transmitter that will put out some 600 milliwatts. So that I'll switch to another image here. I'll stop the share. Trouble is, how do I share my, get my whole screen up here?
On the share screen button, when you press it, there should be like two options. Like you should see like desktop 1 and then other apps. So if you pick desktop 1, and you can share your whole desktop.
I see screen.
Screen, okay,
I
yeah.
do not see screen. Okay, share that. Okay. So now you're seeing my screen. Back to the same image, right?
Yep. Yeah, that's good. We see the whole desktop. Yep, you're good.
Okay. Okay. Um, okay.
Okay.
I'm bringing up a photo of the Tuna Tin S transmitter here. I'm trying to anyway. Okay, do you see it now? This is a picture of the Tuna Tin S transmitter.
Yep, it's good.
Okay. We're looking down into the transmitter as it was designed in the article. And there are two circuit boards. On the left-hand side is the digital board. On the right-hand side is the analog board. There's a lot of wiring. There's a little display on the front of this tin that shows a frequency. To the left of that is a knob that's used to choose the frequency. To the right of the display is the plug-in for the key. And to the right of that is a toggle switch to switch the antenna between the transmitter and the receiver. Looking at this, I don't like the looks of this thing. I'm saying, you know, other people are going to build this. We need to simplify it, and we need to reduce the cost of it and improve it. Engineers never look at anything and say, that's great. They generally say, oh, that's great, except I can improve it. And so the things I wanted to improve were to reduce the size of it, go from 2 boards to 1 board, eliminate all that wiring if we could, put all the connectors on a board. And then we had a big problem that in the analog board, there are these things called bobbins. These little pink things are bobbins that coils were wound on. There are 3 of them there, and there's 1 more over here. So there's 4 of those bobbins. And when the article came out, I went to the website to find, you know, where I could buy those bobbins, and the company that offered them no longer offered them, and neither did anybody else. So those bobbins are unobtainable, and we didn't want to use them anyway. We wanted to use the modern toroids that we use on all our other projects. Another problem I saw is that they were using SMA connectors, and SMA connectors and cables are expensive and are probably not necessary, I thought. So, and the receiver transmitter switching was rather crude with this toggle switch here and required a bunch of wiring. So I told Phil what I thought, and Phil said he'd think about it. And time passed, and next thing I know, Phil's saying, well, hey, I got a prototype. Okay. So now I want to show you Phil's prototype. Do you see Phil's prototype now? It's 2 boards.
Yep, that's good.
Okay. On the right-hand side is a prototyped version of the digital board. And on the left is the prototype that he built with a piece of copper clad printed circuit board for the analog side. Together, it's a complete transmitter. Not all hooked up to run at this point, but that's what Phil turned out, and he did that in no time at all. I think he showed this to me at Christmas time. I got the article first week in December, and I think by Christmas he had this operating. So, and he said he was getting 600 milliwatts out of it. So, which is about the best that can be expected. So, anyway, that was his prototype. I didn't say anything to him, but I went off and did some prototyping too. I'm bringing up another image here. This is my version on a prototyping board of the digital board, the digital half of this transmitter, hooked up to my oscilloscope, showing the output of the digital signal or the input to the RF amplifier. You see that?
Yep, it's good. Yep.
Yeah, you see it? Okay. This trace on the screen here looks like the waves out on Folsom Lake under a storm. They aren't sine waves, but they're pretty close and plenty good enough for this particular transmitter, the purpose of this transmitter. John Kim sails out on Folsom Lake, so he knows what waves look like. I don't know if he's tuned in tonight, but anyway. So that worked for me. I also did a prototype of the RF amplifier, the analog half of this transmitter, and I had a problem with it, and I told Phil about it, and he made some changes. And then finally, Phil came to the board that some 21 of you have in your own possession at this point, and have may or may not have started working on. But here's the final board for the Tuna Tin S transmitter. It's a single board. Everything is on the board. There's no wiring, extraneous wiring. All the connectors are on the right-hand side. All the controls are on the left-hand side. And Phil made various changes and improvements to it, and turned out to be a good little transmitter. So I think I've shown you nearly everything here except my little demo. I have a demo of my Tuna Tin. This is my Tuna Tin. I have it attached to a dummy load, a 12-watt dummy load. Got the 16-volt 18650 power supply hooked up, and a key. If I press the key, I get 12.4 volts. I'm going to do the math to determine what the power output is. Anyway, the encoder is set right now for 100 hertz. As I turn the knob, it moves by 100 hertz. If I push again, it goes to 10 hertz steps. If I push again, it's 1 kilohertz. So I'm now back to 7040.00. Anyway, that's my Tuna Tin. It doesn't look, it looks different than the ones you have, because I got the first version of rewiring to make the display and the clock generator work. And then the encoder didn't work. And so what I did there is instead of doing some rewiring, I just changed it in software. That's one of the great things about a software-controlled radio, is that you can do things in software that you used to have to be forced to do in hardware. So, and of course, the goal these days is to eliminate hardware and replace everything with software, because it's so much cheaper to make changes and easier to make changes. You just you do it in a text editor, you recompile and upload to the processor, and off you go. That happens with my car frequently. About once a month, I get a software update on my car. Anyway, that's my Tuna Tin and video. Did you all follow that video? Did it work at all? I mean, I was having trouble playing here for me.
Yeah, it was good.
With the yeah, it was quite shaky and broken up. I'm not connected to Zoom, why it runs fast and fine and smoothly. So anyway, that's about all I have to say about the Tuna Tin S. I am not a CW operator. I can spell CW, but I can't actually do Morse code and do a QSO. But a number of other people did. The author of the article, the designer of the transmitter, Bob Fontana, he actually had a QSO at 600 milliwatts with a ham in the Canary Islands from his home in Maryland. He also set up a sked with Carol to try to have a QSO with Carol, and Carol was able to hear him with an RST of 229 as I recorded it, but Carol, but he couldn't hear Carol. And that's probably because of the antenna situation. I don't know if Carol's had any other QSOs. I know that John Kim built the Tuna Tin, and he had a QSO with a ham in Oregon, and also with a ham at Santa Clarita, which is in the Tehachapi Mountains, near Six Flags Magic Mountain. And if there are any other QSOs, I don't know about them. I know Carol probably checked out Half Moon Bay. I think Half Moon Bay heard her signal, and maybe the reverse beacon network. That's what Bob
I worked a ham in
said.
British Columbia. I did work British Columbia with it.
I was just going to ask you if you wanted to take over and talk about it. Yeah. So British Columbia is the best at this point?
Yeah, that's the best for me so far. But honestly, I haven't tried very much since then. But conditions are improving, and I think we're going to get some better distance.
Good. Yeah. Anyway, that's about it for the Tuna Tin that I have. Does anybody have any questions at this point?
Yeah, those QSOs were made on 40 meters or what band?
40 meters.
40 meters. Yeah.
Some of us have built them into these little enclosures. Really neat. Little plastic enclosure from Tap Plastics.
Oh. Yeah, if you join our DIY radio group, you would follow that. And there are all kinds of images up in the photos folder. We have files in the files folder. So I think 21, according to Phil, 21 people got boards. I don't know how many people have built them. The people that have built them, or some of the people anyway who have built them, have told us about it, but others have been quiet and maybe haven't even started yet. What we want to say is, let us know and we'll do everything we can to get your rigs built. If you have problems with them, you can hand it to us. We can meet at the library and try to diagnose the problems and get them going. But,
Bob, Carol and I have been playing around with some 2 meter 4 meter 6 meter 8 meter 10 meter 12 meter 14 meter 16 meter 17 meter 18 meter 19 meter 20 meter 21 meter 22 meter 23 meter 24 meter 25 meter 26 meter 27 meter 28 meter 29 meter 30 meter 31 meter 32 meter 33 meter 34 meter 35 meter 36 meter 37 meter 38 meter 39 meter 40 meter 41 meter 42 meter 43 meter 44 meter 45 meter 46 meter 47 meter 48 meter 49 meter 50 meter 51 meter 52 meter 53 meter 54 meter 55 meter 56 meter 57 meter 58 meter 59 meter 60 meter 61 meter 62 meter 63 meter 64 meter 65 meter 66 meter 67 meter 68 meter 69 meter 70 meter 71 meter 72 meter 73 meter 74 meter 75 meter 76 meter 77 meter 78 meter design enhancements, and we came up with a couple of circuits that allow the Tuna Tin to become a full 5-watt actual QRP rig. So there's a lot of experimenting going on out there with tunas.
Yeah, I was going to get to that. And John Kim, I understand, is looking at adding a keyer to his. And I would like to get a receiver to work with it myself, but I haven't achieved that yet. Anyway, any other questions by anybody? We don't have any plans to produce any more circuit boards unless, you know, another half a dozen people spoke up and said they wanted to build it. Why, we would maybe make an effort to do that. Okay, if there aren't any other questions, I'll move on to the TinySA.
Well, first, I just want to say thanks very much to Phil and Bob for the effort put into organizing this project, because it is for bringing a lot of satisfaction to many of us, and it certainly is worth the while.
Yeah, well, we've had a hell of a lot of fun with it ourselves, you know, taking an idea and turning it into a reality. And then we were actually shocked that we got 20-some people to express an interest in building it. We thought, you know, the age of build it yourself was, you know, kind of considered something out of the past. But Phil has said, rightfully, that this is actually the golden age of do-it-yourself electronics. I mean, it's never been better than this. The components that you can get, the tools that you can get, and the low cost of it all. It used to be enormously expensive to build a transmitter when in the 50s, you know, you had to have giant power supplies and everything, and a bunch of vacuum tubes that sold for more than what some of the transistorized radios sell for now.
You know, the other big thing too, Bob, is the availability of information. This whole internet thing has changed the complexion of our world.
Absolutely. You don't need to go to, you know, electronics engineering school to learn everything you need if you're, you know, hard-headed enough to read, study, and put it to use. So I definitely believe in interleaving theory with practice. And somehow I learned through my fingers as well as I learned from books. So.
The technology has advanced tremendously. This little box here that has this synthesizer, frequency synthesizer, that little the 5351 only goes for like $4 or $5. Now, back in the 1970s, I built a frequency synthesizer. It was called the GLB synthesizer. Some of you may have heard of it. It was used with 2-meter FM radios, which back then were all crystal controlled. So you were actually able to build a synthesizer that would allow you to dial up any frequency on the 2-meter band. This was amazing to do this. Well, that synthesizer kit cost about $200, and it was a box filled with all kinds of discrete integrated circuits and about 2 or 3 different boards in there. It's amazing how cheap the price is right now to get so much better performance, and it's just I mean, it's instant gratification. You could send away to Amazon and you'll have it the next day. So it's like Bob says, it's really a paradise now for people who would like to try and do some building. It's really easy. Although Fry's is gone, you just have to depend more now on mail order to get your parts.
Yep. Okay. I'm going to talk about the TinySA. What is the TinySA? Well, it's a $50 unit. It's a spectrum analyzer and a signal generator in one little unit that sells for about $50. So you get 2 tiny test instruments for $50. It does have its limits, of course. It's limited to tiny signals in and out of about 10 milliwatts. But surprisingly, you can do a lot with that. I'm going to demonstrate some of that. I bought the TinySA after reading a little bit about it on the internet, and I bought it from R&L Electronics over the internet. Delivered, I paid $63.39 with an optional BNC to SMA adapter. So with shipping, tax, and that adapter, I paid $63.39. It is not comparable to a $10,000 spectrum analyzer or even a $700 Rigel DSA 705, but it's amazing how close it comes, and that you can actually do useful things with it as well as learn a great deal. So I bought it. It arrived in a box. Oh, I'm seeing the wrong thing here. Huh. Okay, it's running the right thing now. There's a little video here I created. The TinySA is a spectrum analyzer. Comes with these pieces. TinySA is in the center. It's a small unit, about half of the size of a 3x5 card. It comes with USB cable that's used to charge the battery, and there's an interface cable for PC to control TinySA from a computer. And I'll show you later that software in action. It also comes with two SMA cables and a guitar pick for selecting menu items off of the touch screen. It's a color touch screen, and it works nicely. There is also a male-female adapter for SMA connections, and there is an antenna, which I will show in action in the very next video. So I think that's everything there in those intro. Okay. After looking at what I received, I downloaded some documentation. This 35 pages of documentation. I started reading that, and it told me that I needed to plug the USB cable into my computer to charge up the battery. The battery charged up to 4.2 volts. A 1 hour charge will give you 2 hours of operation. And then I also read that I should run a self-test. Just by a couple clicks on the screen, I was able to get a menu item to run the self-test, and it ran 10 self-tests, and they all passed. So I was pretty confident I had a good unit, a working unit. And then I also ran the calibration. For calibration, you run one of those SMA cables from the low connector to the high connector. So there's an output, and then it goes back in, and the software then compares what's sent out with what's received and decides, how to calibrate it automatically for you. You don't have to go through any fancy calibration operation. It's automated through software. The unit also comes with a DFU, it's called. That stands for Device Firmware Update. That interface means that you can update the firmware over your computer. So over time, this TinySA will get better and better. And if they find bugs, they can fix them. I have not actually done that at this point because it's perfectly functional for me, and I had to spend my time learning to use what I had in front of me. So anyway, you got those 35 pages of documentation. That's about the best documentation I've seen for it. I'm going to run another little video now that introduces the unit. The TinySA has two SMA connectors on the left-hand side, and they are labeled high and low. They also have arrows pointing both ways. What that indicates is that you can either have outputs coming out of those connectors or inputs going into those connectors. And I'll show it going both ways later. The low connector is for high quality middle frequency HF and VHF signals. And there are some nice sine waves that can come out of there. And the circuitry is better for acting as a spectrum analyzer. When signals are coming out, it's acting as a signal generator. And we'll show that in action later. The high connector is for higher frequencies above 350 megahertz, UHF band, and the signals that come out of there, generated from there, are more square waves, not sine waves. And I don't think that I haven't tried it, but I don't think the spectrum analyzer is as high quality there either. Although I have not read everything available. Anyway, at the top of the TinySA, there's a USB port for charging the battery and for connecting to a computer. There's also an on-off switch, and I will turn that on now just by pushing it to the right, and you get lights flashing, letting you know that it's on. There's also a jog switch here. You can push it up and down and left and right. So you can operate the device without the guitar pick using that. Anyway, got it turned on now, and it's showing a display. In the lower right is the low frequency, which is 0 hertz, and the right-hand one is 350 megahertz. So we're seeing the electromagnetic spectrum from 0 to 350 megahertz, and it's showing here in the middle that we're getting 50 megahertz per division horizontally. And we're getting 10 dBm vertically. You can see the gradations on the right-hand side showing dBm. At the very top of the screen, you can see that signal number 1, which is marked with a little 1 down here, right there, correlates with this, showing you that the strongest signal that it's receiving is at 240 some megahertz. Anyway, that's that. Let me see now. I'm going to change. I won't do that now. But anyway, that's enough for that video. I have some other videos that I will show you. Okay. I'm bringing up an image of the TinySA with the antenna attached. At least I'm trying to. I don't know how to get that out of there.
You press escape, maybe? Does that make it disappear?
I had escape to work. No.
No, just click anywhere on the screen out of the white box.
Okay. Here we go. Okay. The antenna is attached to the low connector on the left. And I went in and I chose the frequencies to go from 88 megahertz, which you can see down in the lower left. I said right before, but I meant left, all the way to 108 megahertz. So this is the FM broadcast band. And it is showing that the strongest signal is at 96.95 megahertz. I don't know what station that is, but anyway. And then I also, in a couple of clicks, I turned on the waterfall. So here it shows you what you can do. This is like maybe the first good experiment that you might do if you buy the TinySA. Just wanted to show you that. The TinySA is both a spectrum analyzer and a signal generator. So the next image I'm going to try to bring up, God willing and the creek don't rise, is going to show the signal generator in action. Okay. With a couple of clicks on the screen, you can choose the signal generator mode. It's very easy to do. And you come up with a menu that you can maybe see down here. And you can click on frequency, and then you're given the option to choose the frequency. So I chose 10 megahertz, and that's what's displayed on the screen. So that's a nice 10 megahertz sine wave at about 130 millivolts. If I remember correctly, I can barely read it here, but I think that's what it is. But that's enough millivolts to actually supply this 10 megahertz sine wave as a VFO to a WWV receiver that I have here. Anyway, it does a very nice job as a signal generator. The next thing I want to show you is this little video of it operating again as a spectrum analyzer. This is a video to show the TinySA in operation. I have attached it to an Elecraft XG3 RF signal generator, and we'll use it to show the spectrum analyzer in action. The XG3 is set for minus 73 dBm in the 40 meter band with a signal of 7.058. So I will turn on the TinySA by sliding the slide switch at the top, and it shows the standard display. The signal there is no signal from XG3 yet. So I'm going to turn on the XG3. It comes on. The signal appears way to the left here. What I'm going to do is adjust the range of frequencies that are showing. I click with the RPIC on the touch screen, and then this comes up. I can click on frequency, go to start, click to 7 M for megahertz, and so now at the bottom of the screen it says 7 megahertz. Click again, go to oops, stop, go 7.1 megahertz. Now to the lower right it shows 7.1 megahertz, and we can see the signal more centered right now. At the very top of the screen you see that it is showing 7058 megahertz at minus 72.9 dBm. So that accords with the way the XG3 is set up. So that works pretty good. I'll do one more thing. I'll change the level on the display. Scale per division. And I'm thinking I'm going to do 20 dBm here and see what happens. It redisplays and with signal it uses up more of the display. Anyway, that's that little demo. As you can see, well, I should have done this. See if I can go back 10 to this. Yeah, it's reshifting the display up and down. But what we're seeing here is that there's a lot of harmonics off the XG3. It's a very well designed RF signal generator from Telecraft. That's it for now. Thank you. I wish I could stop it. Not wanting to stop. Okay. I have one more little demo here. Oh, I actually two more demos, so hope everybody's still awake. Another video of my Tuna Tin. It's set for 7040, 7.04 megahertz. And over here, I have the TinySA. It's set to range from 7.03 to 7.5. You can see a little signal from the Tuna Tin bouncing around on the screen. So if I pick up the TinySA and move it over closer to the Tuna Tin, the signal jumps up from the oscillator. And if I set it down and hit the key, it jumps up even more. And I'll key, press key, hit three displays, jumps up, and we get some harmonics. I think that's fun. A lot of things you can do. Okay. I have one more little demo. Show you how to control that I can control the TinySA from my computer. I'm not really set up for this, but I'm doing it right now as I speak. I'm connecting the USB to the top of the TinySA. I'm plugging it into my computer. And I turned on the TinySA. Then I'm running a program called TinySA.exe. At least I want to. default configuration file does not exist or is incompatible. Okay. Situation here is that I don't use this computer except on Zoom sessions, so the one I'm used to using is a better computer. Anyway, what will I do here? I think I'll change the frequency to be 98. And the span will be 20 megahertz. And then I'll click run. When I click run, I expect this software to talk to the TinySA and take over the display so that this program will show you the display that would normally be on the TinySA. Oh, error sending command. Not connected, it says now. Great. When I tested, that didn't happen. Tested it twice today, both on this computer and my regular one. So, I'll stop it, I guess. And try connecting. Oh, I don't have a COM port showing here now. Well, that's right. I'm not plugged into the right computer. Okay, Bob. I plugged it into my desktop. I didn't plug it into the laptop that I'm using here. I just did it now, though. And yeah, now I have a COM5, so okay. All right, and now when I click run, it might work. So this should be showing me, oh, that's right. It's showing me the FM broadcast band, but I did not put the antenna on the TinySA, which I will now do and see what happens. So I do see that the screen on the TinySA is blinking a little bit, and now as I'm plugging the antenna in, you can see we're starting to pick up stations, FM stations. I'm pulling up the antenna to its full extension here. All right, so this is the FM broadcast band. I'm showing various stations and how I'm receiving them. And that's all I'm going to show you. I think this is the last of my demos. The first thing I did when I got this TinySA, had the battery charged and so forth, I waited till 7:30 that night, and I went up to the second floor here because I received N6NA repeater signals better up there. And I watched on the screen as people talked on the health and welfare net. That was fun. Anytime anytime the repeater transmitted, I could see the signals bouncing around on the screen. So anyway, that's about it for my demos, I believe. I'll stop this guy. Give myself a second thought. I think I covered everything. There are some resources. If you want to learn more about the TinySA, I would go to tinysa.org. They have a wiki there, and you can download this 35-page document. You can also go to YouTube, and there are several channels, very good channels for the TinySA. The IMSI guy does things. Eric K-Shoke, I guess his name, I don't know how to pronounce it. I think it's a Dutch name. He has one. And then there's a channel called All the Gear, No Idea. There were some very good YouTube videos there. Anyway, that's it for me. I think I'm going to stop the screen sharing. And if there are any questions, go right ahead and ask.
Thanks, Bob. That was great. Has anyone combined the SA with the Nano VNA? Has anyone like combined the two together yet? That'd be pretty cool.
Not that I know of.
Well, the structure of this one seems to be very, very similar to the Nano.
Yeah.
Probably come out of the same factory.
Right. Yeah, the screen looks the same.
Yeah.
A lot of work putting that thing together, Bob. Thank you.
You're welcome. Yeah.
Bob, where did you get it?
I
Where
bought
did
it
you buy it?
from R&L Electronics.
That's right. You said that before. Thank you.
Yeah. Like I said, I paid $63, including shipping and tax and that optional adapter, so that I could connect, using a BNC instead of an SMA.
Bob, is there only one model or are there several models?
There's only one I know of, Bob.
Okay.
Yeah. Hell of a lot of fun for $50. I mean, I have books on radios here, that are $70, And they don't do anything, they require me to read them and understand.
Great presentation. Thank you.
You're welcome, Bob. Nobody else? I'll go off and read a book.
Any other questions for Bob? All right. Thanks, everyone. Have a good evening.
Thank you.
Yeah.
Thank you.
All right. Thanks. Bye.